So dimensional analysis is a strategy to do conversions pretty quickly. Now, if you look at a conversion like this, 5.5 feet to inches, that one's kind of straightforward. The reason being is that you know the conversion factor. 1 foot is equal to 12 inches. Therefore, you can say, well, multiply this by 5.5, and then you get, that would be about 66 inches. Okay. Now, what if you're confronted with something like 5.5 feet to, let's say, millimeters? Okay. Now, this is a little bit more complicated. You can probably deduce some of the steps. For instance, well, if you can go from feet to inches, then you can go from inches to centimeters. And if you can go from inches to centimeters, then you can go centimeters to millimeters. Now, these might not be off the top of your head, but this is something that you can pretty easily do, so long as you can, make these logical steps. Okay, so doing that same sort of conversion, as a very quick calculation like this is kind of off the table. And so with dimensional analysis, we have a strategy. We have a means to do that. So I'm going to set up the dimensional analysis problem where we're going from 5.5 feet to millimeters. The first thing that I want to do is I want to set up 5.5 feet, and then I want to convert that to inches. 1 foot is 12 inches. Okay. Now, whenever I have this, I can now omit or eliminate, I guess, the feet as units, because I've converted into inches. Now, the next thing that I'm going to do is I'm going to have inches converted to centimeters. And I know that 1 inch is 2.54 centimeters. Okay. And now my inches are in the numerator, inches are in the denominator, they'll cancel one another out. So if I did this calculation right here, 5.5 times 12 times 2.54 divided by everything on the bottom, which is 1, well, I'd end up with units as centimeters. So I would have done this calculation where I've converted 5.5 feet into centimeters, but I want to go a step further. Okay, so 1 centimeter is equal to 10 millimeters. So now centimeters are off the table, and now I've got everything that I need. So whenever I do this, or whenever I set up the problem like this, I've got this streamlined system where I multiply everything across the top. So 5.5 times 12 times 2.54 times 10, and I divide that by 1. And my answer ends up being 1676.4, or if you wanted to write this in scientific notation, which I'd like you to do, you would say, well, 2 sig figs are what you're left with, 1.7, or what you started with, 1.7 times 10 to the second millimeters. All right, we'll get after some more problems in the next steps. Okay, another step, or another example here, converting standard 40-hour work week into seconds. So 40 hours, 1 hour equals 60 minutes. 1 minute equals 60 seconds. That's all that we need to do. So 1 hour. Hours will effectively cancel after I have 60 minutes. 1 minute, 60 seconds. Minutes, we're going to cancel one another out, and we're done. 40 times 60 times 60 equals 144,000. And I'd rewrite that as 1.4 times 10 to the, that would be 1, 2, 3, 4, 5 times 10 to the 5th. Okay, there we go, that's good. Next up, dimensional analysis of 65 miles per hour converted, or sorry, 65 miles per hour. So here we've got a number that has 2 dimensions. So I'm going to write 65 miles 1 hour. Okay, so would everyone agree that this is 65 miles per hour? This is another way to represent it, but this number right here, or sorry, that unit right there is mh, m over h, miles per hour. So 65 miles, what I need to do is I need to convert it to kilometers per minute. Okay, so now we have two dimensions that we're converting. We're converting hours to minutes and miles to km. Okay, now I'm going to go ahead and start with my time dimension. So 1 hour is equal to 60 minutes. So what I need to do is I need to put 1 hour, 60 minutes. Okay, so now what I've done is I've placed hours in the numerator so that I can get rid of hours in the denominator. Now what I've got, if I solved right here, I'd be solving for miles per minute, but that's not what I want. I want kilometers per minute. Okay, so now where do I go from here? Well, it's pretty easy. We have our numerator unit solved for. Now what we need to do is we need to resolve the issue that we have with our we have our denominator unit solved for. We need to resolve the issue that we have with our numerator unit. 1 mile is equal to 1.609 km. Okay, so I'm going to type in 65 times 1.609, and I'm going to write out 104.585 km. Okay, divided by, well, that's going to be 60. Now this is a little bit weird. I want to go back to this. I had miles in my numerator and miles in my denominator. Those canceled out. They weren't right next to each other, but the only reason they weren't right next to each other is because I chose to take care of my numerator unit first. Okay, so now I've got kilometers per minute. Plug this in, 104.585 divided by 60 equals 1.74308, and it goes on from there. What I started with was 65. I had two sig figs, 1.7 times, well, actually it would it would simply be 1.7 km per minute. And that's all there is to this. I hope this was helpful, and I'll see you in the next video.